Hello, here the figure shows a prism ABC, and here PQ is the incident ray that makes an angle I with the normal, and after refracting through the surface to the first face AB, it makes an angle R1 inside the prism, and at R2 angle it incident on the second face AC, and it emerges as the with an angle E with the normal in the second phase at the second phase. And here we can say that we have to consider the triangular prism ABC, and angle A is the angle of the prism and we can consider E as the angle of emergence and I as the angle of incidence. Here we can just consider the deviation of the ray of light as it is incident in the angle PQ. So the deviation of the RS emergent ray with the PQ incident ray, we can say that delta is the angle. So we can consider delta as the angle of deviation. When we consider the quadrilateral AQNR, two angles are right angles. So we can say that 90 plus 90 is 180. So when we consider the quadrilateral, total angle is 360. So the sum of the other angles is 180. The other angles are angle A and angle QNR. So sum of this is equal to 180. And when we consider the triangle QNR, we can say that sum of all the angles are 180. So we can say that R1 plus R2 plus angle QNR is equal to 180. So when we compare the above two equations, we get R1 plus R2 is equal to A. This is our first equation, and we can consider the total deviation delta as the sum of deviations at the two interfaces. So we can say that at two faces it deviates little by 1 I minus R1 and E minus R2 at the second phase. So we can say that sum of these deviations is equal to delta. So delta is equal to I minus R1 plus E minus R2. So we can group I plus E, and we can write R1 plus R2 is equal to A. So we get as this consideration, we can say that delta is equal to I plus E minus A can be considered as second equation. So we say that there is a relation between deviation delta and angle of incidence I. So when we plot this this graph as a graph, we can say that angle of deviation is taken as the y-axis and angle of incidence is taken as the x-axis. So we can say that as the angle of incidence increases, angle of deviation decreases first. Then at a point I is equal to E, it again increases, angle of deviation again increases. So we can say that at the minimum deviation point, we can say delta is equal to dm when we can consider I is equal to E, where we can say R1 is equal to R2. So when we substitute all these assumptions in our equation 2, first in equation 1 we get 2R is equal to A, or R is equal to A by 2. And in the same way, equation 2 gives dm is equal to 2I minus A, or we can say that I is equal to A plus dm whole divided by 2. This is our fourth equation. So we got I and R. Then from Snell's law we can write N21 is equal to sin I by sin R. Instead of I and R, we can substitute A plus dm by whole divided by 2 and A by 2. So this is our equation for refractive index of the prism, the glass prism or something. So we can say that this equation can be used to find out the refractive index. And when here we consider another small angled prisms deviation also. here we say that sin theta is equal to theta. So we can say that sin a plus d by m or divided by 2 is equal to a plus dm by 2. Similarly, sin a by 2 is equal to a by 2 itself. So we can say that n21 is equal to a plus dm by a whole divided by a. So a by a cancel and dm by a remains. So we can say that 1 plus dm by a. So n21 minus 1 is equal to dm by a. Therefore, dm is equal to n21 minus 1 into a can be considered as the small angled prism. This deviation says that there is only a little bit deviation when we consider thin angles, thin prisms. So this is the useful relation for a refraction through a prism.